I can, I'm going to try to go a little bit ahead. But so typically you're given things like a density function. So this is a density function, and you're asked to do something with that. So that you have to go back. So they're computational, but you have to go back to the properties and the definitions. So if you go look in, I actually have a bunch of definitions I put out. I think I put them out into, see where I put them. But it's actually in the book, so I didn't want to have to carry the book. So if you go look in the book, they have, the first thing you do is you flip over to the density function, and you'll see the relationship between density functions right there. Right there. So they have the density function, and this is the cumulative distribution function. So you'll need, like all these definitions, I have this definition table sheet that I have my students actually print out and fill in. It's like a formula reference sheet for a pure math class.
Okay.
You need all those definitions to come to mind. So this is the definition. And you need to use the properties of probability density functions to find the value C. So the one you're going to use is this one right here. I don't know if they have it as... Yeah, they have it right here. Right, so my students picked this one up pretty quickly, that they would have to use this. And you just crank that integral. And so the antiderivative of this guy, which people forgot, is C tangent inverse y. Colonel Clark actually believes that these are important skills that you should have. So, but if we don't use it, you get rusty after some time. But integration is actually important. You can actually stick this on Mathematica. So I just took this f of y and integrated it. And then the way you're supposed to do it is you're supposed to do f of b minus f of a. So engineers would probably stick in the infinity and the minus infinity and subtract. Mathematicians take the limit. So I just took the f of b right here is pi over 2, and f of a is minus pi over 2. And it took us some time to see that as a class. So the integration, you can get tangled a little bit in the integration. So this integral right here is c times f of b minus f of a from the fundamental theorem of calculus. And that's c pi, and that's supposed to be equal to 1 by the property of probably density functions. That's theorem 4.2.
Okay.
And then you solve for c. So c is 1 over pi.
Okay.
So where you have problems like this, it's I don't know if I made these problem sets up. So you might have, like this next one is an example of something you might have. So you have here the above probability density function, find this. So it's very similar to what you have, right? The problem is right now that if that was just y there, all you have to do is put 1/3 to 1 as your limits of integration in this integral. Instead of having minus infinity, you put 1/3 to 1, and you just crank it.
Okay.
But it's a y squared,
it's y
right?
squared.
And I think you have a problem with a y square in it. Yep. Okay. So the first thing is to transform that y squared into a y. And so if you solve this inequality right here, you'll get this or this. So that took us a little while to see as a class. Remember that when you take the square root of y, you get a negative number, and it was easier to see it as a number line. So if you think of things as a number line, well, if my y is bigger than 1 over square root of 3 and less than 1, then when I square it, it'll be bigger than 1/3. And if I have it lower, so it's or the other direction, you're going to have it also, when you square it, it'll be bigger than 1/3.
Okay.
Right?
That makes sense. Yeah.
Right. So it was just, it was a rustiness of algebra. So I think between the three of us, Colonel Clark has no patience for not remembering these things. Colonel Watts has no patience for, you should know this is a circular argument, I shouldn't have to tell you that. And I think I have no patience for bad notation. So between the three of us, I think you guys have a hard deal this year. Anyways, now that you have it, it's all plug and chug. It's this or this. That means that it's probability of this plus probability of that, because these are disjoint sets, so you can split them. And then after you integrate, you get this guy, and of course you can crank this on Mathematica. I'm going to ask if we can use Mathematica on our test, because I don't think, yes, fundamentals of Jedi math are important, but maybe this is not the class to kind of visit that upon you.
Okay.
Is that good?
Yeah.
So you should be able to do all of these. So for all of these problems, you would pick up the distribution function you have. Like here, you were given a distribution function. You'd have to look in the book and find out what the uniform distribution is, and then you write your integrals, set your integrals up.
And
I believe this one here is almost identical to the one I just gave you. Yeah.
And then for if you only have a bound on one side, because all of these were giving,
it would
is
go
it just
from
negative infinity
to 1.
Okay. That was the only question I had, because a lot of these were.
And this one you'd have to split into 2 pieces, right?
Because it's not just y.
Right. You'd have to solve that inequality. So you might have an or there.
Okay.
I left off a lot of parentheses. Okay. I just got tired and it did on Mathematica.
Yeah. Because I feel like a lot of these integrals, like, it's getting to the point where you understand the theory and thought behind it and go to these theorems, but the integrals, a lot of that.
Yeah, it can tangle you up. I think, actually, Colonel Clark is right that you have to get kind of back into the frame of things. So it might be good not to pull up Mathematica or Wolfram Alpha now. I know one of my colleagues in graduate school said, well, if your professors know these things, they didn't think it was important you know them, but so I'm thinking it's not that important, but I know it. I know the antiderivative of c over y squared plus 1. I know that.
So it's important, yeah.
Probably it is important, right? So it might be good just to see if you can try to get it without it. A lot of the students thought this was a log. Let me see if Caroline is coming. Okay, so she's coming.